Hello everybody, this is Michael. In this video, we will talk about the register solution 02, coding and simulation. Okay, so from previous video, we know we have the system block like this. So this is the system interface. This is the system interface. This is for the register solution. Okay. So let's take a look how we coding it and simulate it. First, let's open our Visual Studio Code. We create one new file. We save it first. Save. We save it into this folder, FPGA code sequence detect and register. Under this folder. So we name it like sequence detector .v. So this is Verilog code. Okay, we save it. The first things we added some common information. Save it. Okay. So next things we define our module. Our module is this sequence detector. Okay, the same name with your file's name. Okay, so this module has the input clock, input reset, input sequence data input. Okay, output detector output. Exactly with this one. Clock, reset, input, sequence input, and the detector output. Okay. So this is the interface. So next, we needed to define the register. We define this register is 5-bit from 0 to 4. Okay. So we use this to define one register. Okay. So this is define one register. So next, we will use the assign language to compare the register value with the detector target, to see whether it matched the detector target or not. If it is matched, we output 1. If not, we output 0. So we will use the assign language like this. Okay. We will compare the register value with our detector target. If they are matched, if they equal, then we output 1 high level. Otherwise, we output 0 low level. Okay, on the detector pin. Okay. So next, we need to do the register shift. We shift every bit on the sequence shift into the register. Okay. So we use one always language. Okay, we use one always block. So when the system reset, this is a low level reset. Okay, when the system is reset, we reset the register value as 0. If not, on every positive edge of the clock, we shift the data, the bit data sequence shift into the register. Okay, we shift into the register from this pin. Okay. So last things, we needed to edit the end module. Okay, So this is very simple and beautiful code for the register sequence detector solution. Okay, so this is module defined and the variable defined, register defined, and the detector output compare the two values. And this is register shift the sequence in data into the register. Okay, so this is sequence detector register solution code. So next we need to create the test bench code for it. So we knew one file, we knew another file, we save it. Okay, so this time we name it sequence detector and name it like TB. TB means test bench. Okay, TB test bench. Sequence detect test bench .v. Okay, we save it. Okay, for the sequence detector test bench, the first things we need to edit the time scale. Okay, we need to edit the time scale like this. We also added some information for the file trace. Okay, to trace the file. And also we need to define the clock period. We define the clock period like this. So next we will to define the module name. The test bench module name, okay, is also the same with the file name, sequence detector test bench, sequence detector test bench. So next we need to create our test target. So this is our test target is here, sequence detector, it from this file. Okay. Next, we need to define all the variables inside the test target. So we define it, the input variable, we define it as the register variable. The output we define it as the while type. Okay, input is register type, output is the while type. Okay, so this is the variable defined. Next, we need to create the clock, test clock. Okay, so this is the clock. Initial as high level. After that, every half of the clock period, we reverse the clock level. Okay, by this way we create the clock. Okay, so next we will create the initial test flow. We will initialize the test flow. Okay, so this is test flow. The first things we will use the data. This is data source. We define it here. We define it in front of this. We put it here. Okay, this is 24-bit data register from 0 to 23. From 0 to 23. So it's 24-bit. This is a data source. Okay, we will put it here, this position. So it represents this here. Okay. So next, here we will reset the system. This is reset system, low level reset. And we also make the input sequence state be at 0. After 1 clock, we will finish the reset, okay? We will finish the reset after 1 clock period. Okay, so this here is a for loop. The for loop is output every bit of the data to the sequence in, which means we will output every bit of this data stream on this pin, okay? Every bit on this pin, and then delay 1 clock period. After that, we stop the simulation. We also need to define this integer number. So we define it here. Okay. So we define it here. Okay. So this is a for loop to output the data source to the sequence in pin. Okay. Feed the data into the test target. Okay. So suppose it will 11011 here. We will detect one sequence, and here 11011 here we will detect another one. Okay. So we will detect 2 places. Okay, we save it. So this is the test bench, how we create the test bench. And the last thing, we need to edit the end module. Okay, we need to edit the end module. We put this in here. Okay, so we finish the coding for the test bench. It's like this. Okay, time scale, clock period defined, module name defined, variable defined, test target, generate the clock, and the test flow. Okay, so next things, we will open our model sim to create the test project. Okay, let me open my model sim. Okay, so this is my model sim, and we click jump start, and then we click create a project. Okay, project's name is sequence detector. Project's location, we put it into this folder. Okay, we put it into this folder. Copy and paste. And then we click OK. Wait a moment. Okay, it's creating. Okay. We added items to the project. Added existing file. Okay, is here. File name. We browse the file. Okay, is up 1 level. We click this one and press the shift key and then click another one. Choose both of them. Open. OK. Close. And the next step, we compile all of it. Click here, okay? Compile. Okay, so it's successful. Okay, passed the compile. So next step, we click the simulate. We begin to simulation. Start simulation. Okay. Simulation is here. Click the work. Click the test bench. Click OK. Okay, so this is the simulation interface. The first thing is we added our object into the wave interface. Okay, click here, click any places. Here, signal in the region, click here. Okay, it will add the test object into the wave interface. So we move our wave is here. Wave interface. So this is the wave interface. The first thing is we change the test time as like this, 5 ms, and then we click the run. Okay, it will run here. Okay, it is stop here, and then so this is the result. So this is 11011 detect one, 11011 detect another one. Okay, so this is a simulation for the register solution. Okay, so this is this video, and see you next time.